All right. So we're going to start with a little bit of a primer, just get everybody up to speed on what an AMM is. I discussed a little bit what AMMs were earlier today. Essentially a way to create a liquidity for your token. And so I'm just gonna go through a few principles that we're gonna use throughout the session. So, and if you have any questions, just raise your hand, don't be shy. If you have the question, probably 10 other people have the question, so don't hesitate, okay? Happy to go over the content. All right, so we discussed earlier today different types of tokens, and I even introduced a third kind of tokens, which was the MP token. We won't be focusing on those too much today. We'll be focusing on the most basic kind of token, sometimes called an ERC20, which is basically a fungible token. Okay, so these are the tokens that are used to create stablecoins, to create any kind of representation of a currency or anything that can be construed as a commodity as well. On the XRP Ledger, fungible tokens, we call them issued assets or IOUs, as in IOU something. These build on the principles of the existing financial system, and traditionally banks would issue, they would take deposits, and then you'd have deposits in those banks, and then people could write checks. But say if I was at the Bank of New York, I would write a check from the Bank of New York saying, I agree to pay, Mr. Smith so much money, and then this piece of paper would be, basically a check. But actually, then someone could take that piece of paper and say, okay, Luke owes me. Mr. Smith could take it, say Luke owes me $100. I have this check, and now I can use this as currency. And so eventually, that became currency. So the root of all currency is this idea that it carries a promise to repay at some point. It's like a debt, a paper that represents debt. And today, your banknotes, I mentioned this earlier, are essentially the central bank owing you something, right? Okay, so that's how they're represented on chain. And you'll see that when we go and issue an asset, essentially we're saying, the issuer will say, I owe the recipient this amount. And then that token, that manifestation of this debt can then be traded and used as a means of payment. Insofar as you trust the issuer, right? It always comes back to the issuer. If you trust the issuer, then you trust the piece of paper that says this issuer owes me money. If you don't trust the issuer, then it's worthless. So the way it works on the XRP Ledger is we essentially go about and we create these, we issue these assets, we create these tokens, the way I just described, and then you would put them on the DEX, which is a central limit order book, and I'll show you exactly what that looks like in a second, but essentially it's the collection of all the people that all the intents to buy or sell the asset that are centralized in one place, and so the liquidity is shared amongst the entire chain. Or you can use a primitive, which is a blockchain native primitive, which is the automatic market maker, which is essentially a liquidity pool that gets around this. Every time you express an intent on chain, you have to pay something. It gets around this mechanism and makes it more economically feasible. It's cheaper to do it this way and more efficient. And I'll show you exactly how that works. Okay, so fungible tokens. So I was just describing what fungible tokens are. Let's pass that. Again, I have all these slides are on the, I don't want to go too quickly, but I want to also be cognizant of time and spend more time in the code than explaining all these ideas. But one of the first things we're going to do, okay, so I'm an issuer, I've issued my token. One of the first things you have to understand is that because it's a debt, the person that's receiving the piece of paper that says I owe you something actually has to agree to receive this debt. So the receiver is going to express their intent or express their agreement that they can receive this debt. So you can understand this very easily. If we take an example, if I tell you I will give you 100 Luc tokens, you might say, I don't know what Luc tokens are really worth. Maybe 100 of them is not too much. I'll accept and I'll take the Luc tokens and see what happens. But then if I say I'm going to give you 1,000,000 Luc tokens, you might think, oh, 1,000,000 Luc tokens, that sounds like a lot. You know, usually, by the way, usually when you're giving out something, an IOU, it's because you're exchanging it for another services. I know in the blockchain space, a lot of people think that just, you know, money kind of pours from the sky. You know, airdrops are very sort of, you know, how will I make money this year? Oh, I'll just wait for an airdrop. No, that in the real world, what happens is that you're paying something, you're giving these IOUs in exchange for a service, right? So you're in a store, I'm trying to buy, I don't know, your sneakers that I like, and I'll tell you I'm going to give you 100 Luc IOUs, you know, Luc tokens. You might accept that. But if I'm trying to buy your house, you might say, you know, I'm not sure. I don't know. Or no, simply. Okay, so anyway, there's this concept of trust line. The receiver expresses the fact that they agree to receive a token and to receive a certain amount of the token. Okay, so I am good for 1,000 Lucs, but no more. Okay? So we're going to use this transaction. There's a transaction. So everything that is expressed on chain goes through a transaction, right? So I'm going to use this transaction. I'm the receiver. I'm going to say, you know, I will agree to receive these tokens. The only exception, by the way, to this rule is the XRP. The XRP is the native token of the chain, and so you don't have to set a trust line to receive XRP. Anybody can receive XRP. All others abide by this rule. Okay, so this is what a central limit order book looks like. There's all the offers to sell. They go up. There's the quantity of how much people are willing to sell at each price. And then on the bottom, there's the quantity people are willing to pay at each price. What we call liquidity in general is the sum of everything, all the intents that are expressed to buy or sell an asset. That's the entire liquidity. So if there's 3 people willing to trade this thing, liquidity is not very high. If there's 1,000,000 people willing to trade and they're willing to trade in quantity, then you have a highly liquid market, and the market's a lot more efficient because if it's 1,000,000 people, they have 1,000,000 different opinions. The whole point of a market is to express different opinions, right? And to collect the different opinions and to aggregate them down into a price. And usually when we think of a price, we think of one thing, but actually there's 2 prices. There's the price at which people are willing to sell, and there's the price at which people are willing to buy. Guess what? If those 2 match, then the transaction happens, and so there's always the price that people are willing to sell is higher. It's always the case that it's higher than the price at which people are willing to buy, because otherwise it's already matched, okay? So we have expressed here all of the intents to sell, all of the intents to buy, and the intents to sell are above, and the intents to buy are below. So essentially, what does this say? This chart tells us that the maximum amount of this token that I can buy, I don't even know which pair this is 11.25,000. I could not buy more. No one is willing to sell anymore. It doesn't matter which money I'm willing to spend. If I want to buy the entirety of the supply, I would have to basically pay all the price up to the last thing here. So I'd probably have to pay up to $12.75 from, you know, right now it looks like it's around 3 or something, 2 or 3. The same thing, if I was to sell, I could only sell 16,038.38 maximum. Okay, so that's the central limit order book. It's the limitations of that. So I spoke about this already. Why use an AMM? Well, if you're going to use a central limit order book, every time I want to express the intent to buy or sell, I have to put a transaction on chain and I have to pay some fees. So I use an AMM because it automatically allows me to, it automatically comes up with a price that I can trade at. And I'll show you exactly how it works, but essentially it works by putting up the two assets. Usually there's two assets in a liquidity pool, and it allows me to trade from one asset to the other. It takes the AMM takes the other side of people wanting to buy or sell and always gives them a price. So I put my token A and my token B in the liquidity pool, and essentially you have two types of users. You have the people that put up the liquidity. So these are the people that say, I'm going to put up 100 XRP and 100 Lucs. I put them in the pool, and now anybody can trade. So up to can buy 100 Lucs or can sell 100, can buy 100 XRP essentially. The users are the ones that are doing the other side. So you have the liquidity providers, the LPs, and then on the other side you have the users. The users pay the price, and then there's also a little bit of a transaction fee, okay? Because the people that are putting up the assets, they get paid for putting up the assets. The LPs as a group, they decide how much people are going to pay, how high transaction fees are. This is an example, this is an old example, an Orchestra Finance XRP USDC pool. It tells you how much XRP is in it, 461,215 XRP on one side, 254,582 USDC on the other side. And that basically, from this, and only from this, you can determine what the price is. Because the pool will always trade at a relative price of one quantity versus the other, and I'll show you how that works in a second. Yeah, you can, I'm not sure this pool still exists, by the way. This is an old one, so there's the QR code. Okay, so there's been a couple iterations of this. There's discussion around what is the best formula to run these automated market makers. One very elegant and very useful algorithm is basically the idea that the quantity of asset, the first asset, X, times the quantity of the second asset, Y, is equal to a constant. The constant K will never change. So this is a bit of math, but if you have a pool with 1,000 XRP on one side and 2,000 US dollars on the other side, the intrinsic price for XRP is $2 US per one XRP. What is important to understand is that when I swap at the price that will that will result from the ratio after my transaction. So if I swap 100 XRP out of the 1,000, I will only get I will only get 181 US dollars. Why? Because K stays constant. At the end, if I'm putting 100 XRP in the pool, I will therefore need to have 1,818.1 USD to keep my constant K. So it's a mathematical, I would say, it's sort of the way it works. It's this formula is underlying the AMM, and we'll see why it's kind of neat that this works. But this is the basic mechanism. Okay, so let me just, so if I were to do the reverse operation, okay, I would put 181.9 US dollars back, okay, and I would get out of it 100 XRP. And then my pool would be back at 1,000 and 2,000, and the price per XRP would be back to 2. So if I'm going one way, the price moves against me, and if I'm going the other way, the price moves against me as well. And each time I do this, there's a little bit of transaction fee that gets added, and so the value of the pool, very, very little. It's I think it's up to 0.10% or something like that. There's a transaction fee that gets tacked on, and so the value of the pool in general increases. So I have a mechanism by which I can, on a neutral basis, I can buy XRP or sell XRP into the pool, and if I'm doing the same amounts, eventually it just washes. And then every time I go back and forth, fees are earned by the owners of the liquidity pool. So it's kind of neat because what this means is that if there is a liquidity pool out there that has a better price, that offers a better price than I can get on a central limit order book, then I have an incentive to go in and move and do the transaction in the liquidity pool. And what that does is it brings the price of the liquidity pool closer to the market price. Because I'm only going to do it up until the time when it's at the market price, or if it's at the market price or better. And so there's an incentive always to keep the price of the liquidity pools close to the market price. And that's what makes it efficient and elegant in the sense that it's just a simple formula that's driving this thing, but basically coming in and out and being able to transact without anybody having to be there in the middle to take the other side of the transaction. The pool is always taking the other side of the transaction. If the pool gets too out of balance, the price will be extreme on one side, and then there'll be incentive to come and do the trade on the other side. There is a concept of, at any given point in time, the value of the assets inside the pool can be worth less than the assets if you had kept them outside the pool. And that's because the mechanism of balancing out price basically make it so that sometimes the internals of the value of the internals of amounts in the pool are less than the values outside. So this is an example. It's what we call impermanent loss. This is also why, so usually it's a temporary situation because the pools are meant to go back and forth, and as they go back and forth, they realign with the outside price. And then to mitigate this effect, you have this idea of the transaction fees, the fees from the LPs, and they're earning a little bit of interest or a little bit of transaction fees to compensate for this temporary, relatively temporary situation where you could have impermanent loss, okay? But it's important to understand liquidity pools are really designed to kind of be balanced out and be both ways, go back and forth. So when we added AMMs to the XRPL, basically we took the best that existed out there. Essentially, Uniswap is a protocol you might know, so it's essentially based on it's kind of like almost the same thing as Uniswap v3. It's a technical comment really, but the idea is that we're basically just taking a very well established, very well used algorithm to run the pool. And so you get that natively on the XRPL. Okay. So the transactions we're going to use today, so I spoke about the trust line, which has to be done initially when we issue the asset. And then we're going to come and we're going to create an AMM. So we're going to use AMM create. This will initiate the pool. This means at the point where you're creating an AMM, you usually put up both sides of so you put up XRP and your token, for instance. This is what we're going to do. In this case, it's a TST currency. And this will create the initial price and the initial balance for the pool. Just as a side note, if you did only put one token, well, you could have tokens or you can have XRP here. When we say one or both can be tokens, you can create them against XRP, or they could both be tokens if you wanted to. Once we've created the pool, we will deposit some amount into the pool, and this can be done after the fact at any point. You can come, and all the pools that we'll create today, you can first swap the token of the pool to get the new token available to you, and then you can also reinvest those tokens into those pools as LPs. Okay, so this is this deposit function we'll use. The opposite is withdraw. At any point in time, you can come and withdraw. When you withdraw proportionally to the contents of the pool, or if you don't, then there's a trade that happens to make sure that, to give you the, let's say you only wanted XRP, well, then there'd be a trade that would take place to make that happen. AMM delete is a function that we use once all the liquidity in the pools has been redeemed, it is automatically deleted, but because we're in a blockchain space, there's no such thing as infinite loops, and so, or very long-running loops, and so there's kind of a limit in terms of how many things can be deleted, and objects can be deleted at once, and so this is sort of a cleanup function you can use to iterate over and clean up until all the objects are deleted. If you're an LP, you own a part, essentially a share of the pool, and so you can vote. And you can vote for what? Well, you can vote for transaction fees. Okay? So you can change the transaction fees, and so, you know, if I vote for high transaction fees and all my other co-LPs are voting for a low transaction fee, there'll be a blended average of those votes to give you the final. Oh, so it can be up to 1%. And that concludes this little primer. I did create a little quiz for you guys. While you finish that, so for the rest of the afternoon, what we're going to do is this token issuance and liquidity. So if you remember earlier today, we started off the coding session by creating 2 accounts with this function that works only on testnet, which is called fund wallet. Fund wallet created wallets, generated a new address, and then asked the main treasury on the testnet to fund the faucet to fund those wallets. What we're going to do is we're going to start with 2 seeds, and these will be very important because when we go and connect, you know, so you want to keep track of 2 different types of accounts. One is the issuer account, and one will be the receiver account. Because when we create a token, we're going to, so as a company, as Luc Co, when I issue my asset, I'm actually going to have one account that's going to issue the currency, which will be the issuer account, and then I will have my treasury account, which will receive the token, and then from this account, I can now manipulate a positive balance of the token. So I will create 2 accounts, one that will issue the token, and another one that will hold the tokens that I want to use. And so very often there is the question of, you know, what is the supply of my token, right? So if you have control over the issuer account, theoretically you could continue to print and create money out of thin air. You can create issue tokens for as long as you want. So you probably need some way to, so there's several different strategies, but usually one strategy is I'm going to say I'm going to create a fixed amount of my token, and that's it. I won't create any more. And I can prove this by basically destroying the issuer account, or what we call black holing the issuer account, which means that I no longer have access to the secret, and it's in a sort of blocked state, and so the issuer could never issue more of the asset. This allows me to create, let's say I wanted to create a finite supply of Luc tokens. I would create 1 million of them, and then I would black hole my issuer account, and now all of a sudden, that's it. There's only ever going to be 1 million Luc tokens, not one more, not one less. If I'm managing a stablecoin, for instance, I would introduce a mechanism in which people can get assets, so give me dollars in the real world and get dollars on chain. So that means the issuer account is going to create those tokens, or redeem those tokens for assets in the real world, where I would pay back the issuer. I would destroy those tokens on chain, and then I would unlock the dollars in the real world. Does that make sense? So there would be a mechanism going back and forth between my tokens and the real world, and so in that case, you know, we're talking about, I want to create a token that is backed by the US dollar, say. It's 1-to-1, and then that means that I need I need those dollars in the real world, and I need people to trust me. By the way, remember how I was saying, like, we can represent all these things on chain, but at the end of the day, you need to trust the actual the person that's writing, the one that's writing the data on chain. You need to trust that entry point. Well, this is the same thing with a stablecoin. You would trust that, say, Circle or Ripple with the Ripple USD, RLUSD, are good for the dollars that they're giving me on chain. In our case, we won't worry about that. We'll just say you can create as many as you want, or I'll let you decide how you want to run your thing. You can advertise with your friends how you're going to run your own treasuries. But what's important here is you're going to have an issuer seed and a receiver seed, right? We're going to have two accounts. And so in my code earlier, I started setting up an issuer account and a receiver account. And so I was calling them issuer seed and receiver seed. So if you have these at the top level of your code, that's cool. Some of you will be and then to create the accounts, I just do this from seed. So what that looks like is I have issuer seed, retriever seed, and then I basically well, I can just take this code once I've done that. Just nice. So I'm kind of doing this. Whoops, sorry about that. Back to here. I'm doing this, what I've done in other, let's see, so a lot of you came to me and said, okay, the code, I'm following the code orally, but sometimes I get lost, or I got sidetracked. You can always go to the bottom of these activities and get the actual full code. So issuing a token, this is the whole create token file. We're going to go through it step by step, but I'm going to show you how it works. Essentially, and the point that I was making here is that we want to have this issuer account and receiver account as a constant, as something that's in our code. We're not going to generate those accounts, and we're going to actually keep those accounts. If you want to go all the way through to the activity, what's really important is that you really isolate these two accounts, because we'll be using these accounts when we set it up in our wallets. And the account you want to set up in your wallet will be the receiver account. So this one is for the activity. Okay, we want this. So really, the situation we want to be in is we're going to change a couple of different things, but we want to keep the issuer seed and the receiver seed all the time. Even though we're going to copy paste code and do all of that, we want to keep those seeds separate. So really, if you want to put this on a different, in your notepad or someplace else, keep these, because we don't want to lose them. Okay. So, and if you want to recreate these from scratch, all you need to do is come into the welcome page, and you go into faucets, or you can just Google XRPL faucets, and you could create, at any point in time, you can create new accounts. But once you've started issuing currency, you're going to need to be in control of the issuer account and the receiver account. Otherwise, you need to start over each time. Tedious. So I'm going to make sure I'm not deleting these. Okay. So we've created our accounts. Now, okay. So the first thing I'm going to do is I'm going to create I'm going to create a new function. Now, I can do this in directly in the main. Let's see. I'm going to need this helper function. What this function does is I'm going to have a name for my currency. In my case, it's Luc. It's a three-letter code. But for this to work for everyone, three-letter codes kind of work out of the box. But for this to work for everyone, you can have longer names of your token. I could call it Lucky, for instance. I need to transform it into its representation on chain, which is a hexadecimal string. And so in order to do that, I have this converter function. So I take this converter function. So I'll do, okay, so just so you know, I'm going to do the version where I do it in the main piece of code, in the main index. And then I'm going to create a special file that's going to contain the create token functionality, okay? But to start, I'm just going to do it this way. There's a little mistake here. Okay. So previously I was using XRPL deconstructed, but now I'm just using it directly. And so wallet is subname space of XRPL. So I create this function, convert strings to hex padded. It complains because it's not used yet. That's okay. So I simply copied it into this top component of my script. Now I need to enable rippling. Okay, so this is an account feature that I need to set on my account so that when someone trusts me and someone trusts someone that already trusts me, then everybody is in the same group. It's not a one-to-one relationship. It's like we become part of a whole. So let's say I'm an issuer. I set you set a trust line with me. If this gentleman sets a trust line with me, then you guys can also trade that same token. And so anyway, enable rippling is something that we need to do, and this is a feature that you set at the account level. So it's going to be need to be set on the issuer, right? So, but right now I'm just going to copy this function over and add that to my stack. Okay, so now I have convert strings to hex padded up here and enable rippling. You can see it's always the same structure. I'm building an account function. I'm building a transaction, which in this case is account set. I'm saying it's an account set transaction type. I'm specifying the wallet address, and I'm setting this flag, which is what I'm interested in using this function for. And then in this case, I could have used directly submit and await, but I'm deconstructing. I'm saying first I'm signing. I'm preparing the function, which basically does, you remember I was saying you need to have some kind of ledger state initially on the transaction to know that you are aware of where the ledger stands. So that's this line, the prepared. Then I'm actually signing it. This is how you would sign it. And then I'm submitting the transaction and waiting for the result. So it's important. Previously, we were doing the really simple version where we were doing it all at once. The reason, why would we want to do this in a separate way? Well, because I want my user to sign. So I'm going to prepare the transaction for my user. I'm going to then give him the opportunity to sign this transaction. So that's when he'll get a confirmation screen on his wallet. And then when I receive that transaction back, I can send it to the ledger, and it will be signed by my user. And I never see my user's private key. In this case, we are the issuer and the receiver, so we own both keys. But this is just to show you how it would be deconstructed into those 3 steps so that you could present the transaction to your user signs it, and then you submit the final transaction. Okay? So that's the rippling. So then I'm going to actually go and do the thing. So the first thing I need to do is I need to enable rippling. So now I'm going to go down to my main function. I'm going to gut my function, just remove everything from here. Okay, so notice my main function is now really, really simple. We good? And I'm going to first enable rippling. The wallet I'm using is the issuer. The issuer will enable rippling, okay? Then I'm going to move on. So I could, at this stage, I could definitely go in and run this. So I will do that, why not? Okay, so I have an error already, so that's good. Let's see. This here is XRPL.accountSet. Okay. Here I had a little error. It's XRPL is what I want to use. So I'll run that. So it's going to wait 4 seconds because it's actually writing data on chain. It's an actually proper transaction. There. All set. Looks good. Next step. I'm going to actually create the token. Okay, so this is when cutting and pasting the code won't work entirely. You need to be careful of a few things. So I'm going to take this create token function. Okay, this is a separate file. Okay, we're going to create a separate file. Ready? I'm going to come in here, and I'm going to use this plus button, and I'm going to create a file that's called create token. And I'm just going to paste the content. Let's just go over what this actually does. So I'm importing a few types from XRPL. Payment. So this is, I'm importing the actual payment model here, but anyway. And here I'm going to create a function. So to create a token, what do I need? I need an issuer. I need a receiver, which is going to be my treasury. I'm sending in the client, which is the client that I'm creating in the main function. And most importantly, I'm going to send a token code. And so when we go to use this function, you're going to need to update your token code, or you're going to need to personalize your token code. What does this do? Well, the first thing it does is it creates a trust line from the receiver to the issuer. Remember, the receiver can't receive anything unless there's a trust line. So I create a trust line, in this case for 500 million tokens. I can receive up to 500 million tokens from my issuer. And the way I specify a token is I specify it always with the token code that we're going to create and the issuer's address, right? So in order to identify a token, not only do I need how it's called, but I need to know who the issuer is. So we could literally, all of us, issue USD on chain, but it would come from different issuers. And so we want to make sure that we're identifying the right token, and the right token is the token code and the issuer. Okay? So this is my receiver saying I'm willing to receive 500 million of this new token from this issuer. I prepare the trust line transaction, I sign it, and then with a receiver account, and then I submit the transaction. So now, once this is done, this should say success, it worked, I created the trust line. Once I created the trust line, then the issuer needs to come in and actually issue the token. It's very easy to issue the token. All you need to do is create a payment. So we've already done that. We already know how that works. So we're creating a payment from the issuer address to the receiver address that just set the trust line. And we're going to specify an amount. And when we specify an amount, earlier when we specified an amount, we only had value here directly, which was an XRP value. XRP is a sort of a first-class citizen on the chain. You don't need to specify the issuer or anything. It's already a first-class citizen. It's the native asset, so you don't need to do anything special. But for any issued asset, you need to specify not only the currency code, but also the issuer in addition to the amount, right? Not just the amount. If it's just an amount, if it's just this value, then it would assume it's XRP. So here I'm specifying it is this new token that I created from this issuer. And here I'm logging the actual payment payload, preparing the payment, signing it with the issuer's account. So the issuer is now going to send out this payment to the receiver, and then I'm submitting the actual transaction to the ledger, waiting for it to complete. It comes back with the results, and now I have two accounts, an issuer account and a receiver account, and one of them has this new token. So what's kind of weird is that the first time we ever use the token code is from the receiver's point of view. He's saying, I am willing to receive this token from you. This token doesn't exist. This is when it's materialized on chain. Is the first transaction that is signed is actually signed by the receiver and not by the issuer. So you have to wrap your head around that a bit. In the order of things, the receiver is the first to move. And he just kind of determines so. But in practice, how it works is that you're running your product, you're running your service, and you're preparing a transaction for the receiver to accept your token, and so you're the one who's saying, this is the token that I'm willing to send you. Are you willing to accept it, if in fact? And then the receiver will sign a transaction, and that will then be submitted on chain. And so the first transaction on chain that has anything to do with your issued asset is a transaction that's signed by the receiver. That's the result of it. Great. And so how do we use this function? Well, we simply create a token, issuer, receiver, and then token code. This is where I always see a lot of Luc tokens being created. And so I will show you here. Okay, so I created this create token function. I'm going to go back to my main here. I'm going to, I don't need, well, I may need print money later. You never know, right? You never know when you need to create money. I'm going to import create token. And I'm going to go back to my main function. So this is my main function. All the other functions here are helper functions. I don't really need to worry about them. But I do need to worry about the consistency of this function. This is where things, in this function, things can get messy. I'm going to keep this enable rippling just because I can. It will essentially, every time this runs, it will just set the same flag over and over on my account. It's not a big deal. I'm keeping it here so that you remember that we need to do this before creating the token, right? So remember what happens inside the create token function? The receiver sets a trust line, and the issuer sends a payment. Here, I'm going to decide that I'm going to create a new token. It's going to be called LOL, okay? That's just me. You should all choose your own token. So you can use your initials, you can use whatever. Try not to make it too long, and it has to be it can't contain any spaces, I don't think, or anything like that, so be creative, but okay. And so I'm going to now run this. And it'll probably fail because I didn't go and look at some of the amounts that I was creating, but let me just, yeah, okay, so my issuer created a trust line for 500 million tokens, and my payment is for 200 million tokens. So this means that it'll work for the first two payments, and then it'll fail. So the first time I run this, oh, it's failed, okay. Let's see. So basically I'm debugging. Create token does not provide an export. Okay, so did I forget to export? I guess I did. Yeah. So here we just need to do export. Okay? Oh, no. I'm actually, yeah. It's all good. I just, here I used another different, slightly different type of export, but the result is the same. It's just that, see here how I'm importing a between curly brackets. Because I just added that export, it should work, but really the way it's intended to be used is like this. It's the whole thing. I'm importing the whole thing. We good? Okay, let's get started. Drink some water. Pray. It's technology, it should work. So Here I'm enabling rippling. I am setting the trust line. That worked. And now I am issuing a payment transaction. As you can see, my currency is obfuscated in some way. It's encoded, hexacoded. It's not saying LOL like I just created. But that's what this parses to. And then the transaction goes through, and it looks like it worked. And I can go, and now I can see, I can load up the testnet explorer. My payment was successful. I successfully paid 200 million. So let's see. Let's say somewhere what this is. So I now have 200 million of these. So let me just go see that the destination account has 27 XRP and also has, so they've very nicely added fake LOL because it's not a trusted issuer, it's just me playing around. But my LOL token is a 200 million, has a 200 million positive balance. This is this last transaction that came through, and it came through from this account. So if I click through that account, so there's actually a slight bug here because it says positive 200 million, but it's actually negative 200 million. So anyway, I know. Welcome to blockchain. Things are a little confusing. If I did a good job, I could probably print my balance somewhere. Delivered amount. So for fun, let's just do that. Let's see. If I run this again, it's going to do that transaction again. What I'm really interested in is getting my balances. So remember how I get my balances. I can just, if you're like me, you don't like to type, especially in front of everybody. I can see your typos. You just come in and get, get the code from up here. And so I'm going to use get balances here. So create token, right underneath here. I'm on purpose running this again. It may fail. And this should be issuer and receiver. Okay. And so I'm going to run this again. I think I'm going to increase my payment from my issuer to my receiver from another 200 million. So let's see if that worked. Enabling rippling, transactions going through, payment going through, and my issuer has a negative 400 million balance, and my receiver has a positive 400 million balance. Yes? Say that again? Can you say that louder? Sorry. I think I can. Like that? So what's really important is just my main function. Remember, especially for those that aren't familiar with TypeScript, this is when you get tripped up. You have to write your code inside of this. All the action is happening inside of this. You might have helper functions here above, but all the action is happening inside. Okay? Okay, so who has managed to issue their currencies? What's your token code? BAT? BAPT. Okay? Yeah. Anybody else have a cool token name they want to share? What's your token name? Okay. Anybody else? What did you do, Josh? Huh? Coded? Okay. I don't know, 1 billion? 100 billion? Oh, 542? 89, okay. Good. All right. If you need help, raise your hand who wants to create a token and has not. Guys, yeah, Matisse, where's Matisse? He's helping someone. Oh, you're helping. Okay. They watch? Yes. This is the create token file. By the way, the create token file, oops, sorry, is right here, right? Issuing tokens, right here. You can literally just copy it from here. I will still show it to you again. Raise your hand again. I think there's a group over there that needs help. So these two functions I copied over. What's important here is I always want to keep this part up here. And then I'm creating my wallets right here from my seeds. A couple more things we need to do. Well, let's just go and create an AMM, okay? Everybody has their own little monetary kingdom now. And we're just going to move forward and create an AMM pool. So we're going to create a file called create AMM. So at this point, just know that you actually need to have your issued token with an issuer that has a negative balance and your receiver that has a positive balance. Keep your issuer and receiver seed. And as we move into the next part, we're going to create now an AMM. So by this point, you should be pretty familiar with what we're going to do. It should be quite familiar. We're going to create a new type of transaction. So first we create the payload. So to create an AMM, we need to use this transaction called AMM create. So remember, when we create the AMM, how can I say this? Yeah, so we're going to actually, when we're creating it, we're also depositing to the AMM at the same time. So in my case, let's see. I don't have that many XRP, so I'm going to actually, so as I'm copying this code, so first of all, okay. So we're going to create a new file called create AMM, right? So what is it going to do? It's going to create a new transaction, AMM create. Transaction type is AMM create. The account it's coming from is the receiver address, right? It's the account that has the positive balance, the receiver of your token. I'm going to set the trading fee here to 600, which is basically 0.6%, I think. The amount is going to be, there's two amounts, amount 1, amount 2. You can see here my first amount is I'm defining a token, and my second amount is I'm defining XRP. So in this case, you can see here I'm defining it with 50 XRP. If you've printed money into your account, you might have 50 XRP, but I don't, I'm pretty sure I don't have 50 XRP. Most people don't. So I'll have to change this, and then I prepare the signature, prepare the transaction, I sign it with my, so in this case, it is the receiver address that's creating it, and I'm submitting it with the result, and I'm logging the result. So let's do that. First of all, I'm going to go back to my code. I'm going to create a new file. It's going to be called create AMM. I'll paste this code in there. Now, I'm going to actually change this to be only 5 XRP. So 1, 2, 3, 4, 5, 6 zeros. Okay? And I have a lot of tokens, so I'm going to at least do 20 million tokens. Okay? So 20 and then 1, 2, 3, 4, 5, 6 zeros. Great. So when you run this, if you come into like insufficient funds error, it's because the AMM you're trying to create, you don't have the money to create the AMM. So you need to have some liquidity. Okay. Now back to here. I've already created my token. I don't need this part of the code anymore. I've already enabled rippling. I'm going to gut all that out. Okay. And I'm going to go to the top of my file, and I'm going to import my create AMM. Okay, so let's see, making sure I'm exporting it as default, so I should be importing it like this without the brackets. Okay, create AMM. Okay, remember I have all of this other stuff in my code. I want to keep this. I want to keep this. You know, I'm not right now using these, but I don't need to delete them, but I need to edit inside my main function. So I'll come in here and I'll say await, create AMM, and these are my values. Okay, so issuer, I need receiver. So someone, I saw in someone's code, someone was using a different variable name for their issuer account, their issuer wallet. Like if this was issuer wallet like this, I'm just going to show you. The proper way to use that wallet would be to say, use this syntax. Okay, issuer maps to issuer wallet, because it's expecting a variable called issuer. Okay, so I'm not doing that. I'm just keeping it simple. Whoops, of course. There we go. So issuer, create AMM, issuer, receiver, client, and token code. Okay, my token code should be the same, right? Because I want to create an AMM with a token that I created for myself. Okay, now going back into the AMM function, it takes my token code, it uses it here. And the amounts here need to make sense. It needs to make sense. Like we created 200 million of our tokens, or maybe 589, depending. So you can't create an AMM with more than 589 if you've only issued 589 tokens, right? And then here, this is the amount in XRP. In this case, I changed it to 5 XRP in my case, 5 and 6 zeros. Okay? So that looks pretty good to me. Let's run it, see what happens. This is the transaction. So far, looks pretty good. Create AMM transaction. Let's see if that worked. Plug in this hash in here. Fail. Unfunded. Uh-oh. Okay, let's see. I have 26 XRP here, 8 XRPs here. I was trying to do 5. 1, 2, 3, 4, 5, 6. Okay, this should work. Let me make sure receiver is this guy. He's got 26 XRP. Okay. Five, 1, 2, 3, 5, 6. Oh, there's something wrong with my currency code. This token code here needs to be converted to a hex. Okay, I don't actually own this thing. I need to actually do this. Let's see if that was the problem. It looks like it worked because, see, my balance here is less. And now I have, wonder why this balance is less. Okay, this is my issuer account, and I have a new token in my possession. You see here? So let's go see what happened with that transaction. That was successful. I created a liquidity pool with 20 million tokens and 5 XRP with a trading fee of 0.6%. Okay. Now, if I go to this account, this is, okay, so my account, what is my account? Let's see. So this guy created an AMM, and now I have 20 million less of this, of my LOL token, and I have this other token. It created some LP shares for my token. Now, what I was interested in, I'm going to answer my own question. So I created this account from this issuer address. Okay. So this issuer has a 200 million negative balance and a 9 XRP balance, roughly. Programmatically, this is interesting. I would have to understand. I'm not sure I understand exactly what's happening, but the you see here I have a balance. Oh. Yeah, I'm not sure why, but I have two balances for this token. So I have my negative 200 million, and then I'm not sure what this is, to be honest. Or did I try to issue, I wonder what this is. Anyway, you may or may not have this, but my issuer account has a negative balance. It looks like it has a balance against the AMM for some reason. Anyway, okay. Okay. Okay, so now So the point at which you need to get is the point at which you have a successful create AMM transaction from your issuer account, okay? So I know this because I have create AMM transaction here, and it is successful, okay? And I have the amounts that I'm interested in. So who's managed to do that? Raise your hand. All right, okay, cool. So now we have a little activity, have a little fun. For those of you that need help, just raise your hand and we'll, our technical partners will help you come in and fix you and get up to speed. But what I want you to do now is go to your phone and download a wallet called XAMAN, if you don't have it already. It's called XAMAN. From XAMAN app if you want. And I'll show you how to fast track to set up an account for yourself with the receiver account. Okay, a couple of things we need to do. The first thing we need to do is when you open XAMAN, well, it'll have you, if those of you who don't have it already, it'll have you go through some onboarding things, so you just kind of have to skip through them. For the others, you go all the way down to the right here into settings, advanced, and you need to enable developer mode. Developer mode will give you access to the testnet from your wallet. Yeah? You need to do this from your phone. Once you've done that, go back to the middle. Go back to the home screen. At the very top here, if you don't have any accounts, you should have a button that says create an account, add account. So I already have accounts, so I'm just going to do add account from here. And then I'm on a screen. Wonder if I can share that. I could probably share that, but anyway. So instead of creating an account from scratch, I want to import an existing account. Full access. And I'm going to choose the second option, which is family seed. Family seed private key. And here, I need to paste in my receiver seed. So I'm going to go get in my code. It's nice on being on a Apple device because it can just paste it over, but otherwise you can maybe email it to you or copy it over. I'm going to confirm that. I'm going to say understand. I'm going to give it a name, which is 42 Training 2025. Okay. And now I have this 42 Training account on my phone, the issuer account, the receiver account, sorry. At the top right, you should switch to testnet, okay? Right now, you're going to be by default on the XRP Ledger. You should scroll down to XRPL testnet and select that testnet. And you should see, in this receiver account, you should see all your assets, including the AMM tokens, including the tokens that you issued from your issuer account. So for the last part, now, all of those that have the XAMAN account set up with their receiver account, we can go to the training app, which is this guy. Here the code is, let's see, training April 2024, like this. So I'm going from this last item here, create an AMM pool, from the token issuance and liquidity documentation. you have the address trainings.xrpl at with the password. Gets you in here. I submit the password. I'm going to connect my wallet. So you don't need to do this. I do this. You should do this on your own computer. And what I do is I come in the middle of examen, I scan a QR code, and I connect my wallet. Oh, look at that. Not the only one. Then I click join the training, and I put in my name. My name's Luc. And I'm here. And let's see, what can we do? So I can see I should be able to see my tokens. I have some LOL tokens, and I have some of these tokens which correspond to my AMM. So let's see what other people are doing. Real Deal. Connected his issuer account, apparently. So Real Deal, you connected your issuer account, not your receiver account. Who's Real Deal? You need to do it again with your receiver account. Close, though. And well done for doing it on your own. Okay. Xac. Oh, this looks like something interesting. So I'm going to view this AMM. So one of the things I need to do when I'm connecting to an AMM, I need to set a trust line for that asset so I can actually interact with the asset. So I will do that right now. Scan this for me. So the app is proposing me to sign a trust line for this currency. Okay. Right. So now I have a trust line, and total capsa. Ooh, he's got a lot of XRP. Oh, interesting. So anyway, so what do I want to do? I want to exchange one XRP to this token. Same thing. Sign that transaction. Get myself 10 million how do you pronounce that? Who created this token? Xac? Who did that? You did. So your friend, he managed to do it with the right account. How does that make you feel? Not great, right? He also has a lot of that token, like billions worth. Well, I got me some of that. And so go ahead, interact with other people's, let's see, Baptiste. Clearly. Oh, now we're talking. Baptiste 2, I'll try that one. Baptiste, I'm going to set up a trust line. Okay. Now, that was easy. We can all collect each other's tokens. We can all manipulate each other's tokens. We can send transactions the same way. Extra credit, if you can deposit, once you've converted the token, once you swapped out for the token, can you then deposit into the liquidity pool? Okay? So all of these are AMMs, liquidity pools. This one right here is the address of a liquidity pool. And right? And so I should be able to deposit into this pool because I have some of those tokens. Extra credit if you can get that. And if you do succeed, let us know. and maybe you'll get some swag if you're fast enough. So a lot of you have managed to do this. This is great. These are mostly successful people that have managed to get onto this webpage. So what did we do? We decided to launch a really cool service. And for that service, we wanted a utility token. And so we each one of us issued a new token on chain. To do that, we first created two accounts, an issuer account and a receiver account, which is going to be our treasury. Okay, it's going to hold our assets, it's going to hold our token, it's going to be the main source of our tokens. So for most of us, we created 200 million of some brand new, super cool token. Then, once we had the treasury account, the receiver account set up with this new token, in order to do that, by the way, we had the receiver account had to set a trust line to the issuer token, and then the issuer was able to send to effectively create the tokens by going negative on that balance. Okay. So the issuer has a negative balance of 200 million of your new token. The treasury receiver has a 200 million positive balance. Okay, we're clear. Now I take my receiver account, and my receiver account has some XRPs as well, and is going to facilitate my users being able to buy my tokens. And so to do that, I'm going to create an AMM, a liquidity pool, where I place some XRP and some number of my brand new token. Of course, in order to do that, I have to have that balance of both tokens. So my token is no problem, but maybe I need to have some XRP in there too. Okay, I set that up, great. Now, all of my users, which are essentially represented by everybody in the room, are able to transact on the AMM and purchase the tokens when they need them. And this way, people have given me XRP, and I have given them my token, and now they have my token, and they can use my token in my services, and they can benefit from all the value of my token. In the meantime, I've received XRPs. So this is actually a very common way to fund your business, is to basically you're receiving XRPs as your users are coming in and buying tokens that they're using and that they're holding, and then they're eventually using it in your services, and you're getting XRP, you're getting a steady stream of XRP. Every once in a while, it's your own liquidity pool. You're coming in, and you're adding back some of your tokens, and you're getting XRP out of your pool. What I mean is that this is actually a very logical, viable way of funding your program, insofar as the token you create has any value to your users. Okay? Any questions? I think they're doing something a little bit different because they're creating, they're not, I don't know, we'll have to ask them. We'll have to ask them. They're creating they're using a new type of token, which is the MPT token, multi-purpose token. But they may have used liquidity pools, so we can ask them. I know for a fact that there's some companies in the space that use this. They have but you have to have a strong utility token ecosystem, otherwise the value of your token will go to zero very quickly, and no money will be made, no value will be created. Congratulations, everyone. You know how to create liquidity on the XRP Ledger. You've dabbled with liquidity pools and AMMs, which are actually, pretty advanced stuff. I mean, blockchain, we're deep in the stack, and AMMs are definitely even deeper. So, well done. And I think we'll reconvene 5 minutes before 5, so that we make sure we're on time for the centigrade presentation. So see you in just a few minutes.